So this one we're going to get into what happens when a cell is not at standard 1 molar. So let's talk about why your battery of your phone dies. Obviously, if you don't plug it in, it dies. So let's talk about why. What would happen to the concentration of the 1 molar Cu2 plus and the 1 molar zinc 2 plus, this is our original Voltaic cell, as we allow this battery to run? The Zn2 plus will increase because that zinc is becoming Zn2 plus. Okay, you might remember that we do send in some NO3 minus to counteract it, but it's super soluble because it's NO3 minus, so it's not going to make a solid or anything. So Zn2 plus will increase, and copper, the Cu2 plus is becoming copper, so it's going to decrease. So then we're going to change our solutions or our concentrations. Batteries go dead when the voltage is too low. Okay, the concentration of the reactants become too low. So the reactants here are zinc and Cu2 plus. And the concentration of the products become too high. So when the Cu2 plus gets too low, because it's getting lower and lower, and the Zn2 plus gets too high, that is when the battery voltage stops. So changing the concentration will change the voltage. Okay, that seems pretty clear, but we don't know exactly how. Well, we do, but we haven't talked about it. So this goes to the Nernst equation, which we've talked about in some form. And so here we're going to be using Q. Okay, so this is the Nernst equation. The E cell is the E naught, that's when they're 1 molar, minus this number, which is the natural log of Q. Now this number right here, you're not going to be expected to put other values in here, okay? So you might just have a number to put there. So they might just give you a number, but you're not going to have to put in R, T, N, and F. So they will just give you a number to put in place of this business. And then you know how to find Q. Q is the concentration of the products raised to Y over the concentration of the reactants raised to X. Okay, so that's not new for you. We've done that before. So at standard conditions, the reason we don't have to deal with this business is because at standard conditions, if they're both 1 molar, 1 molar, 1 molar, Ln1. The log or natural log of 1 is 0. So at standard conditions, E equals E naught. So we don't need the rest of this business. But as the reaction proceeds, they are no longer all going to be 1. As the reaction proceeds, products concentrations increase and reacting concentrations decrease. So this is going to go up, this will go down, and then Ln will become greater than 1. A number greater than 1 is going to have a positive log. So you can see when you plug it into our little Nernst equation here, this will be a positive number, the log. And so this is going to be lower. If the reaction proceeds long enough, the battery, quote unquote, dies, not because the reaction is totally gone, not because there's like no molarity or whatever, however you want to phrase it, but because they eventually reach concentrations that no longer generate enough voltage. When Q becomes really big, large number. The log of a large number will be positive and eventually big enough to equal E naught. Okay, so the bigger that Q is going to get, the bigger this number is going to get. And then this will be equal to this. And so we'll end up with E equaling 0. So when E equals 0, it doesn't mean that we don't have any reactants or products left. It just means that we're at equilibrium. So E equals 0 is equilibrium. So let's take a look at some different scenarios that we could find. If we set up a cell with more reactants and less products, so if we have more reactants, less products, Q will be less than 1, right? Because if this is smaller, then this number is going to be less than 1. When you do that, this becomes a negative number, and so E increases, because E naught minus a negative number is obviously going to be bigger. So E will be bigger. So that's increasing the voltage. With the voltage of a galvanic cell that was set up with non-standard conditions, copper 2 at 2 molar and zinc 2 at 0.1 molar increase, decrease, or stay the same? It will increase. And let's see why. So Q is going to be this over this. So if we have 0.1 over 2, that is obviously a lot less than 1. And then our Nernst equation is this. When Q is less than 1, we are further back away from the dead battery, equilibrium. So the voltage increases. So that's using this number line. When Q is less than 1, we're down here, and we're further away from where the battery dies. If we have more time to get there, the voltage is higher. Another way to think of that is that when Q is less than 1, the log of Q is negative. So if the log of Q is negative, then this whole thing becomes positive, and obviously this is bigger. So there's two ways to think about it there. So if we had Cu is 2 molar and zinc is 3 molar, what would happen? So we take another look at our Q. Our Q here, our Q here would be 3 over 2, so Q is greater than 1. When Q is greater than 1, if we look at our number line here, we're closer to where the battery dies. So that means the voltage is lower. You can also use the Nernst equation. If Q is greater than 1, the log is positive. So this right here stays negative, and this will be lower. If they're not 1 molar, but the same molarity, then Q would equal 1. When Q equals 1, log of Q is 0, so E equals E naught. So it will stay the same. Now, I want to just make a little side note here. That is because this is 1-to-1. Okay, that's not always going to be true. It's not like when they have the same concentration, they're automatically going to have a Q equals 1. This galvanic cell was set up with 0.5 and 0.5 will have the same voltage, but how long will this battery last compared to a cell at standard conditions? So it has the same voltage, but how long will it last? And this might seem very hard, but it's actually something that you could easily figure out. You have the knowledge already. What this is saying is that in this reaction, we're going to have less stuff. That means the reaction happens faster, right? It's basically just a limiting reagent problem. Less chemicals means that the reaction happens less times so that the flow of electrons stops sooner. Okay, that's all that means. Less chemicals, shorter reacting time. So now let's take a look at something that's maybe not one-to-one. If we do a copper-silver voltaic cell, we are not going to be one-to-one because our balanced net ionic equation is going to be okay. Now the reason I knew that copper was going to be the one that we flip is because that's the only way we could make the voltage E naught a positive number. Okay, if we flipped this one and made AG the negative number, then we would end up with a negative E naught value, and that would not be favored. So that's how I knew that copper would be the flipped. So when you do that now, remember to change the sign on the one that you set to oxidation. And so this is our E value, E naught value. Remember we said at the end of the last video that it doesn't matter that it's 2Ag and 2Ag plus, that doesn't change this number. This is E naught is an intrinsic property. It does not change based on the amount. If NaCl was sprinkled into the silver compartment in a precipitate form, so AgCl would form, would the voltage increase, decrease, or no change? So Ag plus would precipitate as AgCl, reducing the Ag plus concentration. So let's take a look. Q for this would be Cu2 plus over Ag plus to the second power. If this was to go down, then Q would be much higher. If Q is greater than 1, then the log of Q is going to be positive. So this would be positive, which means it would decrease because this little value here would stay negative. So it will decrease. And then this last question has to do with what I kind of alluded to a little bit ago, where here, if we set this up with 0.5 molar of each instead of 1 molar, what would happen to the voltage? Now, before we said it would stay the same because it was a 1-to-1 ratio. But here it's not a 1-to-1 ratio. So our Q number okay, it's not, if you put 0.5 in both of them, it doesn't come out to be 1. It comes out to be 2. So the voltage is going to decrease. All right, so be careful about that. It doesn't automatically mean that when you have the same molarity, you're going to have the same voltage.